All right, as we get started, go and take out your homework. Books open to page 29. Textbooks open to page 29. You did numbers 1 through 37, the odd. 1 through 37, the odd. So 18 problems, just miscellaneous practice with different processes that we've been working on. Overall, really just more of a review than anything over all this stuff. And then we're going to go into some new material today. Good. And yes, there it is. Good. All right. Number 1, we're just rewriting without negative exponents. So moving things around, taking reciprocals. Audrey, number 1, your answer? Good. A squared p cubed over g to the 4th. Number 3, same type of thing. Abby?
H to the 14th, x to the 4th, k to the 13th, r squared over f squared.
Good, except keep alphabetical order. So in the numerator, put the h to the 14th first, then the k to the 13th, then the r squared, then the x to the 4th, all over the f squared, just so we keep them alphabetical, but otherwise good. Number 5, rewriting without denominators, just moving the denominator up using negative exponents. Noah?
C squared, b to the negative 3rd, a to the negative 8th, and b squared.
All right, minus a point, same thing as the last one, keep them alphabetical order. So the a to the negative 8th, then the b squared, then the c squared, then the b to the negative 3rd, but otherwise good. Number 7, same type of thing. Michael?
A to the negative 2nd, c to the 7th, e to the 12th, the g to the 27th, and m squared.
Got it. All alphabetical order and everything. Good. A to the negative 2nd, c to the 7th, e to the 12th, g to the 27th, m squared. Are there any questions on 1 through 7, the negative exponent stuff? Again, this is kind of our last look at it before our test, which isn't for about 2 more weeks. So we're not really going to see a whole lot more of this for a while. Questions at all on negative exponents? How many went 4 for 4 on the first 4 homework problems? All right, Audrey, you understand? All right. Let's see, number 9, evaluating the expression when x is 2 and evaluating when x is negative 3. What did you get when x was 2? Really big number here. Brandon?
I got 385.
385 is correct. Great job. What about when x is negative 3? A little smaller, but we got to be careful with the signed number, Maddie. 93, no. Genesis?
247.
Not quite that big. Audrey? 85 should be our answer. How many got 385 for the first one? 385 for the first one. Okay, so several of you missed it, or a couple of you missed it. How many got 85 for the second one? Okay, fewer of you on that one. Okay, so let's quickly take a look at this one. We have the 9x squared. Of course, we're squaring a 2, which gives us 4. So it's really 9 times 4. I'm going to do that part in my head. Plus, and then it's 12x. It's 12 times 2, class. 24 over, and then 2 squared again becomes the 4. And then plus, and then it's 2 plus 5, or 7 cubed. Maybe this is where we had problems. You should have memorized 343 years ago. Maybe forgot about that over time. I don't know. And then here, of course, we get a 6, and then here we get a 36. So maybe this was the problem, not getting the number there. Add it all together, though. It does come to 385. Questions now that we've seen this worked out? And how many found the mistake on letter A? You said, oh, I see what I did wrong. Sort of, okay? Not really.
I got 85 for both, but I got that, but somehow I wrote 85.
Right here, you got that, and then that became 85?
Wait, was the answer 385?
385.
Oh, I probably forgot the 3.
Okay, all right. And then for the negative 3, of course, here's the key. When you square a negative 3, that's negative 3 times negative 3, class, positive 9. So it's 9 times 9 is 81. Then we've got a 12 times negative 3, class, negative 36, because positive times negative. But we've got another negative 3 squared, so another positive 9. So right here, class, it's going to become negative 4. Now, if you forgot the negative, if you had a positive 4, that's where you would have had a 93 for your answer. I think somebody said 93. You said 93. Did you have the positive 4? Yep, that would have caused it there. And then the negative 3 and positive 5 class combines to give you 8. Ooh. Negative 3 and positive 5 gives 2. Cubed gives 8. There we go. And this is where our 85 would have come from. Again, if you actually got an 8 cubed, 512 or something like that. Questions on A or B? Do we find the mistake on B? Because we had a few of you with mistake on B. Questions. All right. Number 11. You're just adding polynomials together. Let's go back to Maddie.
9x squared over 5x plus 31
Good. 9x squared, positive 5x, positive 31. Number 13, we had to distribute the 2, and then distribute a 3, and then add together, Genesis.
12n squared -35n + 78.
Ooh, really close, just at the end, class. Negative 78. Should have had a negative 6 and a negative 72. Remember, add and keep the sign to get the negative 78. Did you have the negative 6 and negative 72?
Yes, I did.
And just kind of, your brain slipped into multiplication mode, where negative, negative, and multiplication is positive. Addition, negative, plus another negative gives more negative. All right, number 15, distributing, Abby?
Negative 12x to the 5th, positive 24x to the 4th, negative 8x squared.
I think you mean x cubed?
Oh, x, yeah.
You did have a cube? Okay.
Yeah.
Negative 12x to the 5th, positive 24x to the 4th, negative 8x cubed is correct. Number 17, multiplying a sum and difference. Square the first, square the last, put a minus sign between them. Hopefully Noah did that. X squared negative 16. Number 19, same thing. Another sum and difference, another difference of squares. Michael?
R squared negative 121.
Good. R squared negative 121. Number 21, are we good on 15, 17, 19, by the way? 15, 17, 19, any questions? Any questions at all? All right, number 21, foiling. Brandon.
I got x squared negative 6x negative 6.
Ooh, okay, you multiplied the first, you multiplied the outer inner, and then added those together, and then you added the last instead of multiply the last. That was happening to us in the last lesson, too, or a couple lessons ago. Negative 16, there we go. Number 23, curious to see if you did the same thing. So give me what you wrote for your answer on 23.
Negative 20x squared, positive 42x, negative 18.
Okay, so you got that one then. Okay, so maybe just some sort of slip on 21 then. Good. Negative 20x squared, positive 42x, negative 18 our answer. Number 25, what did you get for your answer, Genesis?
6x plus 6xy minus negative 72y.
Okay, real quick, you got a 2x times 3x gives 6x squared, and then same thing at the end, the 8y and the negative 9y gives negative 72y squared. So there's little tiny details, little things can get us sometimes. Number 27, some double distribution, Audrey.
X cubed minus 4x squared minus x plus 4.
Great job, x cubed, negative 4x squared, negative x positive 4. Number 29, triple distribution. Maddie.
Negative x squared, negative 8x cubed, positive 39x squared, positive 46x, negative 84.
Great job. Negative x to the 4th, negative 8x cubed, positive 39x squared, positive 46x, negative 84 is correct. Number 31, another triple distribution. Michael.
21y to the 4th, positive 41y to the y cubed, positive 21y squared, negative y, negative 2.
Very good. Number 33, when you were squaring the binomial, square the first, square the last, multiply and double. That's what people are going to forget if they mess up, is they forget to multiply and double. Or they forget that whenever you square something, you always get what sign, class?
Positive.
Positive. What should we have gotten for number 33, Noah?
X squared negative 4xy positive 16y squared.
You just forgot to double. You squared the first, squared the last, multiplied. What should we have had in the middle? Yeah, x squared negative 8xy, positive 16y squared. Number 35, another binomial being squared. Genesis.
4x squared plus 36xy 9y squared.
You multiplied and squared. By the way, I think that's the first time this year I've seen that, but I've seen a lot of that in the past years I've taught, is multiply and accidentally square. So 2 times 3 is 6 times 2 doubled is 12, not 6 times itself for 36. So 4x squared positive 12xy. Positive 9y squared, but I've seen that a lot, so definitely not a mistake unique to you. Number 37, there's an easy way, and there's a hard way. How many saw the easy way? Yes. Remove the parentheses, combine like terms, and turn it into a 10 cubed minus 1 squared. To get square the first, square the last, multiply and double negative 20 cubed. And then there's the long way, which I don't feel like showing right now. How many got this answer for number 37? All right, questions on 37. Did you do the long, hard way? Did you do it at all? Okay, question? All right, any questions at all on the homework? Was anyone perfect on the homework? That's a really long assignment to be perfect on with a lot of little details. How about 2 or fewer? Missed 1 or 2, just 1 or 2 problems on the whole assignment. Okay, wow, a few of you good. Just 3 or 4 problems missed. Just 3 or 4. 10 or fewer? Just kidding. All right, questions on the things that we missed. Any questions? All right, next section in your notes. Next section in your notes. Dividing monomials. Dividing monomials. First thing I want you to write down under dividing monomials is we set up the problems as a fraction. Just write the word fraction. To divide monomials, we're going to write the division problem as a fraction. But you realize division is simply the inverse operation of multiplication, right? And with multiplication, we said we got those 3 steps, class. Thank you, Genesis. Sign, number, letter. Well, guess what our 3 steps are going to be for dividing, class? Yeah, sign, number, letter. So with the sign, it's the same rule we had for multiplication. If the signs are the same, you get a positive. If the signs are different, you get a negative. It's not the same for adding signs numbers, but multiplication division it is. If the signs match, positive. If the signs are different, negative. Then we come to the number. Now this is where things are a little bit more challenging than multiplication. You can always multiply 2 numbers together. 17 and 58. They can multiply, but you can't divide them, can you? Division's a little bit more picky. So here's our key with number. Write this down. If you cannot divide, reduce the fraction. And that's why it's so important to write it as a fraction in the first place. So you can see it right in front of you and you simply reduce it down. If you can. Like if it was 17/58, don't reduce. So you're done. Okay? But if it was 17/68, 1/4. Right? You could reduce that one. So number. If it doesn't actually divide, just reduce the fraction. And then of course we come to letters. And remind yourself of this, that when you divide like bases, subtract the exponents. To divide like bases, subtract the exponents. Write that reminder to yourself. I know it's already in your notes once. Doesn't hurt to write it a second time. To divide like bases, subtract the exponents. And I actually want to start there with a quick refresher. If I have x to the 7th divided by x cubed, class, what do we get?
X to the 4th.
X to the 4th. You subtract the exponents. What if I had a squared divided by a to the 4th? What do I get? I hate negative exponents. So what's the better way to write it? 1 over a squared. You still subtract the exponents. Just as you said 7 minus 3 is 4, you say 4 minus 2 is 2. But where do you leave the answer? Not in the top where the more were, but in the bottom where the more were, or where the fewer were. For instance, this is AA over AAAA, right? Cancel, cancel. You have a 1 over AA, 1 over a squared. Okay? And that's perhaps the best way to think of it, is leave it in the denominator. What if I had m cubed divided by m cubed? Well, when I subtract the exponents, class, I get m to the 0, right? But we also learned when we were very small that anytime you divide something by itself, it's always equal to 1, which is why anything to the 0 power equals 1. But of course, we could just say they cancel, but remember in division when you cancel, you get a 1. What if we had, write this one down, negative 3a squared b divided by ab cubed. Well, let's go through the progression. My 3 steps to dividing these monomials, class, are sign, number, letter. My signs are different, so I'm going to get a negative. I've got a 3 divided by, there isn't another number. Well, technically, class, it's an understood 1, so 3 divided by 1, 3. I've got an a squared divided by an a. What's that going to give me when I subtract the exponents? A to the 1st, or just a. Again, it's not 2 minus nothing, it's 2 minus 1, so 1a remains. I've got b divided by a b cubed. Subtract the exponents to get 3 minus 1, class, is 2, but where do I leave the b squared? In the denominator, like so. Any questions on this? All right, we've done similar things this year already. Write this one down, 12. X to the 5th y squared over 3x y squared. If you don't see signs, that means they're both positives, and since they're the same, we're going to get a positive, which I'm usually too lazy to write. We'll divide the numbers. Hey, we can divide easily this time, right? 12 divided by 3, class? 4. And I've got an x to the 5th divided by a single x gives me, class, x to the 4th, and then I've got a y squared and a y squared. What happens there, class? They cancel. Technically, you could put a 1, but anything times 1 is itself anyway. Do I need to write the 1? Only if there were nothing else left in the numerator. But I've got other stuff here already, so we'll just say my answer is 4x to the 4th. Feeling like this is pretty easy? We got this. Nobody's brain blown, whatever the word is. How about this? Negative 5x y squared z to the a over negative 10 x cubed y squared z. That's why I checked to make sure we were good, because I knew this one was coming. Really not bad though if you follow the steps. What sign is my answer going to be, class?
Positive.
Positive. With the number, can you divide 5 by 10? No. But you can reduce 5/10 to get what, Noah? 1/2. And then we take care of the letters. I've got an x divided by an x cubed. What should I get, Michael?
2x to the second.
Where?
At the bottom.
X squared in the denominator, x squared in the bottom. What happens with the y's here? Genesis? They cancel cleanly. Here, this x canceled with one of the three to give me 2 left. Okay? And then literal exponents? Well, when you divide like basis, class, subtract the exponents. Here's an a, here's a 1. Well, I know that like 5 minus 1 is 4, or 3 minus 1 is 2. What's a minus 1? A minus 1. So I get z to the a minus 1. That's it. You have a binomial exponent. It looks ugly. You feel smart. But we're done. Technically, if you looked at it from the other point of view, if you subtracted this way, just like we said 3 minus 1 is 2. We kind of subtracted that way, so we left it in the bottom. The alternative would be to say z to the 1 minus a, and you could leave it in the bottom. Generally speaking, though, unless there's an obvious greater power in the denominator, we think top down. A minus 1 is preferred, so that would have been the correct answer. A 1 understood, z to the a negative 1 divided by 2x squared for our answer. Questions on what to do with literal exponents? Welcome to Algebra 2. I think we saw that in Algebra 1. No, Audrey's giving me a nod. She remembers that. Maddie just woke up, so I don't know. Write this one down. 4mn squared divided by negative 6 m to the 4th n to the x. Or we could say n to the x power, but that's hard to say, so n to the x. 3 steps, class? Sign, number, letter. What is my sign going to be, Audrey? Negative. What about the number? Brandon?
It's going to be 2 over 3.
2/3. We'll reduce it down. What about my m, Maddie? M cubed in the bottom. And what about the n, volunteer? Abby?
N to the second minus x.
Good. N to the 2 minus x. Again, technically, n to the x minus 2 in the denominator would be acceptable, but we prefer things in the numerator as a rule. So I love her answer. How many thinking the same thing Abby said, even though you didn't raise your hand? Questions on what Abby did with that literal exponent? All right, turn your textbooks. Oh, not turn in your textbooks. We got the next thing in your notes. Dividing a polynomial by a monomial. Dividing a polynomial by a monomial. Give you lots of notes before we practice. Dividing a polynomial by a monomial. And our notes are the exact same, so you don't actually have to rewrite them. We're going to make it, set it up as a fraction. We're going to do sign, number, letter. We're going to do the exact same steps. Write these examples down. Suppose we had a polynomial like ax squared y minus 2xy squared. And here's one way it may be written in your textbook. It may be grouped together as a polynomial and then say divided by negative xy. Okay, that's one way you might see the problem. But I said we want to write these as fractions. So we're going to put a fraction bar. We're going to put negative xy underneath of it. We're not going to have it written out to the side. And by the way, The fraction bar does the grouping, so we no longer need the parentheses. Do you see the proper way to set up a polynomial divided by monomial problem? And it's going to be sign, number, letter. But just like distribution, you multiply sign, number, letter once, sign, number, letter twice, sign, number, letter 3 times, sign, number, letter 4 times, however big the problem was. We're going to divide sign, number, letter once, sign, number, letter twice. Make sense? So, ignoring the existence of the negative 2xy, let's just focus right here, class, sign. Number? 1, technically, I guess, right? We don't have to worry about it because there are no numbers. Letters. Well, the A has no friends. There's nothing to divide the A by. So, class, it stays A. In the numerator, technically, over 1, if you wanted to write that. X squared and X, class. X to the first. Technically, again, in the numerator. Y and Y. Don't cross them out, though, because you need the Y for the next division. But mentally, cross out the Y. So, negative AX. Technically over 1 if you want to think of it that way. Now we come to the next sign, number, letter. Sign. Number. 2 divided by 1 is 2. X's? Cancel. Y squared and Y? Here's my answer. Do you see it's really the exact same thing we're just doing? You just had to do it twice. No difference. Okay? Just sign, number, letter, and then another sign, number, letter before you're done with that problem. Keep walking over to the lectern as if my notebook's there, but it's over here. Write this one down. 9 ax cubed minus 12. A cubed x to the 5th. I can feel my voice going. Positive 6 ax to the 4th. All divided by 3 a squared x squared. It's okay if my voice goes. I'll just have Brandon come up here and teach the class. I'm kidding. All right. All right. How many times are we going to have to think through sign, number, letter, class? 3, because there are 3 terms in that numerator. 3 terms in the polynomial dividend. Technically, the bottom is our divisor. But we're going to focus just right here. What do we get when we divide sign, number, letter, Genesis? Where? On the bottom. A in the denominator. Keep going. Where? In the numerator. So we get a positive 3x over A. Right now, we're going to focus our attention right here. Sign, number, letter, Audrey. All in the numerator this time, right? Now we're going to focus our attention here. Sign, number, letter, Noah.
Positive 2 over A. 2x squared over A.
There we go. Progressively sign, number, letter. Do you see how to work that? Questions on what we just did? Let me give you another one. Keep doing that. Gotta just set it over here, don't I? Gotta be smart. Negative 5. X to the A, y to the 3m, plus 20, x to the 5th, y to the m, all over 10, x cubed, y to the 2m. Don't be daunted. Think through the same 3 steps, class. Sign, number, letter. You're going to be mumbling it in your sleep. I'll be like, Brandon, it's noon. Time to get up for lunch. Oh, sign, number, letter. Sign, number, letter. Brandon, you're having a nightmare. Oh, Mom, it's you. Oh. Anyway, all right, so let's take a look at this. We'll put our answer over here. Brandon, you have the nightmares. Sign.
Negative.
Number.
1 over 2.
Letter.
X A minus 3.
X to the A minus 3.
And then Y M at the top.
Y to the M. Good. 3m minus 2m is 1m, so just y to the m in the numerator. Okay? How many so far so good thinking what he was saying? All right? And then Genesis, I'm going to have you finish it. I'm going to give myself enough room. Sign, number, letter on the last one. What do we do with the letters? Or what do we do with the exponents? Subtract them. Here I've got 2m, and here I've got 1m. What do I get when I subtract 2m and 1m?
Negative. So it's gonna be at the bottom.
Right, so all over.
Y to negative.
Well, if we think bigger one down here, right, because 2m is definitely bigger than 1m, so 2m minus 1m equals 1m, or just m. Technically, if you put y to the negative m, it's not wrong, but I don't prefer the negative exponents. In fact, quiz and test directions may expressly say no negative exponents. Good. Questions on this? How many think in the same answer Genesis gave? Questions. What about decimals in our division? It's Algebra 2, right? So this is my last chance to throw all kinds of things at you. So all the things I spared you from in Algebra 1. Here they are. Okay, but what about decimals? Help me remember when you were in elementary school and for the first time you saw a decimal in the division problem. And what did the teacher tell you? You can't divide by a decimal. And remember you had to move the decimal out of the divisor? But what you did outside the division house class, you had to do inside the division house, right? If you move the decimal 4 places out, that was a really bad problem if that happened. Maybe she was mad at you. You moved it 4 places outside the division house class, you had to move it 4 places inside the division house. Well, here we are using the division house right now, but you realize this is outside the house, this is inside the house, and you can't divide by a decimal any more than you could when you were in elementary. So we have to move it. How many times? Once. And what you do outside the house in the divisor class, you have to do inside the house, which is the dividend, which is our top. So in other words, what you do to the bottom, you have to do to the top. To everything in the top. So if I'm going to move this decimal over once to make it a 3, I have to move it over once here, class, to make this 27. And once here to make it 300. And here to make it 90. And now we're back to what we were doing before, and it's really not that bad after all. That make sense? Questions on what to do with decimals if they appear? All right, here we go. Sign, number, letter. Abby, first sign, number, letter.
9x squared y to the n minus 2.
Perfect, and said with great confidence. Maddie, the next sign, number, letter.
Like the 100 line and then a y.
Oh, over y? Why do we put a y underneath?
Oh, no, y cubed.
Y cubed, there we go. The x's cancel with each other, and then y to the 5th, y squared, subtract the exponents, y cubed. And then the last sign, number, letter here, Michael.
Negative 30x cubed over y to the 2nd.
Or, in other words, over y squared. So there's my subtraction there. Just kind of goes downhill like that. All right. By the way, quick note that technically a plus or a positive negative signs go in front of the fraction bar, technically, which is why I kind of swooped it down there. Questions on this? Yes, ma'am.
So do you only put the y squared under the 30 and not just make one big line and put
Oh, good question. Because the y squared isn't the denominator here, is it? And it's not a denominator here, it's only a denominator in this term. So great question, yes. We don't put a y squared for all of it, just for this particular sign, number, letter. Great question. Good, I actually should have thought to mention that myself, so I'm glad you thought to ask. Thank you. Good, any other questions? This is why recordings are better when there's students in the room. All right, questions on this? All right, now I give you a chance to work some of these. Not in your book, though. So I'm going to give you 3 of these to work on your own. Let's see if you can go 3 for 3 here. First one's going to be a negative 45, x cubed yz to the 5th, being divided by a 20a x to the n y cubed z squared. And I'll put the next 2 up while you work that. Abby's got her answers. Brandon got his answers. Take one more minute. Pencils down, check your answers. On the first one, negative 9x to the 3 minus nz cubed over 4a squared or 4ay squared. How many have this answer? Every sign, number, letter. Question, Michael.
I just got x squared instead of x cubed.
Okay, all right. On the next one, negative 7 over 2b plus 2ab squared minus 3. How many have that answer for the second one? Perfect. And then for the last one, negative 9a over b plus 30a squared minus 20c to the 4th over b. How many got that one as well? All right, question there, Michael.
Nothing.
All right. Any questions at all on dividing monomials? Feel like we've got a good handle on that. All right, so next thing in your notes, dividing polynomials. Dividing polynomials. And for this, we're going to have to use long division, not fraction bar. So for this, when you're dividing by polynomial, you have to do it like long division if you'll write that in your notes. So dividing by a polynomial, just write down long division. And the steps for polynomial division should look somewhat familiar to you. Remember from your elementary days, divide, multiply, subtract, compare, bring down? Well, we get to skip the compare step because we're dealing with algebra instead of numeric values, but the steps are the same. Divide, multiply, subtract, bring down. A couple things though. First of all, write yourself a note. You want to make sure that your dividend and divisor are in descending order. Make sure that your dividend and divisor are in descending order. So for instance, if we are dividing here, like an 8x cubed minus 22x squared plus 17x minus 3. Notice the descending order, cubed, squared, first, gone. We also want the same thing here, though there's only two terms, so first, gone would be descending. And from there, step number 1 is to divide the first by the first. Those who've had me for Algebra 1, you're like, that sounds familiar. Yeah, divide the first by the first. Don't just write down what's on the poster. Write down divide the first by the first. Here's what that means. Divide the first term by the first term. Just divide the first term by the first term. And guess how you do that? You're dividing by a monomial now, right? Dividing by polynomial? What? Well, we just learned divided by monomial. We're good with that now. So just divide monomial by monomial. Sign, number, letter. What do we get, class?
4x squared.
Positive 4x squared. I'm not going to write positive, but positive 4x squared, right? Step number 2, multiply by the whole divisor. Step number 2, multiply by the whole divisor. In parentheses, you could say distribute. 4x squared times 2x, 8x cubed. 4x squared times negative 3, negative 12x squared. And we're going to write it down underneath, making sure to line them up under the like terms. Step number 3, it says on the poster subtract. I want you to write on your paper add the inverse. Add the inverse. So instead of a positive 8x cubed, negative 8x cubed. Instead of negative 12x squared, positive 12x squared. And when I add the inverse, these two terms should cancel. Here, we're left with a negative 10x squared. And my fourth step, bring down. I have two terms right here. So I need to have at least two terms here. You could bring everything down, I suppose. I'm just going to bring down the next term, though, because I'm too lazy. I'm just going to bring down the positive 17x. And then you notice the arrow takes you back to the beginning, just like long division in elementary school and in junior high. Divide the first by the first again. When we divide sign, number, letter this time, class, we get
Negative 5.
x. Negative 5x to the first, right? And then we multiply. Now again, multiplication is the distribution. We're going to multiply what we just wrote down by the divisor. Of course, that gives us the negative 10x squared, and this gives us a positive 15x. Then we need to add the inverse. Change to a positive, change to a negative, these cancel, and right here I get 2x. And I'm going to bring down my negative 3. Then we divide the first by the first. 2x divided by 2x?
1.
They cancel to give you 1, not 0, 1. Of course, we know 1 times anything, class, itself. So 1 times 2x negative 3, Noah, 2x negative 3. And when we add the inverse now, they both cancel, and I'm left with 0, which means no remainder, which is really nice. Though, write this in your notes, if you get a remainder, you'd write it as a fraction. So for instance, let's suppose instead of a negative 3 right here, this had been a negative, I don't know, 8. Well, in that case, they don't cancel. Negative 8, positive 3 would have left me with a remainder, class, of negative 5. Well, in that case, I would need to write this as a fraction. Watch. When you write the fraction, the sign of the remainder goes in front of the fraction bar, whether it's a positive or a negative. Here it's a negative, put that in front of the fraction bar. If this had been a positive, it had been left with a positive 11. Put a positive in front. The numeric value goes on top. The divisor is your denominator. And so you simply write your remainder as a fraction, if you have one, and you hope you don't get one, because we don't like those. Questions on this? How many remember doing this in Algebra 1? Okay, several of you. Okay, a little bit? No, not at all. Okay, well, we'll take a little longer to catch up. Write this one down if you would. A squared minus AB plus B squared. And do not copy my dividend. You're going to rearrange it. I'm going to write down this. 6a squared b squared minus 5a cubed b minus 4ab cubed plus b to the fourth plus 2a to the fourth. That's all messed up. That's not in the proper descending order. Now notice there's 2 letters, A and B. One of them will descend. It's your choice. But notice, A squared, first, gone. Since the A already descends here, let's make the A descend. Which of these terms has the highest power of A, class? The highest power of A. The 2a to the fourth. So that's what you should write in the first spot of your dividend. What's the next highest power? The negative 5a cubed b. Then the next highest power of A?
6a squared.
The 6a squared b squared. And then?
Negative 4ab cubed.
The negative 4ab cubed. And then finally, we've got 4. 3, 2, 1.
B to the fourth.
Gone. Positive b to the fourth. And now we're ready to go through the process of long division. What's the first step after we've got the descending order? Audrey? Divide the first by the first. Michael, what do we get when we divide the first by the first?
You get 2a squared.
2a squared. We write that up here in our answer. Second step is to do what, Michael?
Multiply.
Multiply by all of this now, right? What do we get when we distribute a 2a squared?
You get 2a to the fourth, negative 2a to the third, a cubed b.
Here we go.
Positive 2a squared b squared.
And then what do we need to do, Brandon? Subtract, or the inverse. There we go. Add the inverse. So we're going to change all of these signs. I'm going to add the inverse. What should always happen with the first terms, class? Cancel. And that's going to leave me with what, Brandon?
Negative 3a squared, cubed b, and positive 4a b squared.
And then I need to make sure I've got enough terms for over here, Genesis, so I simply bring down the negative 4ab cubed. Technically, you could bring down the other one with it, but you only need 3 terms, right? So I'll just bring down the 1 extra there. I'll save the b to the fourth for later. And we go back to the beginning, Abby. Once again, we
Divide the first by the first.
And when I divide the first by the first, what do I get, Abby?
Negative 3ab.
Negative 3ab. And once I've written that down, Maddie, what do I need to do? Distribute to get
Negative 3a and positive 3a squared plus negative 3ab cubed.
And then what do I need to do, Noah?
Then you
Add the inverse. Go through and change all of these signs. Of course, first terms will always cancel. Then no, I'm left with
a squared, b squared, and negative a b cubed.
And so then I've got two terms. I need one more class just. Bring down. I'll bring down the b to the fourth and then back to the beginning again, Audrey.
2
Divide the
the first
first by the first. And when I divide a squared by a squared, I get
b squared.
b squared. And once I've written that down, Genesis, I need to multiply or distribute the b squared to get
A squared, b squared, negative a b cubed, positive b cubed.
And when I add the inverse this time, everything cancels, no remainder, which makes me quite happy. Questions on this now that we've done a second one? Those of you who've had me before or maybe learned this in the past, you say, yeah, I've got this now. I feel like I've got it. I know Michael, feel like you're getting the hang of it. Okay, you'll practice a few of these with your homework tonight. I want to show you one more example of the kind of crazy that can happen, though, in Algebra 2, just so when you see crazy, you're not overly thrown off by it. Write this one down. We'll divide an x squared plus 1 into an x cubed minus 3 plus x. Those who had me in Algebra 1 might remember that missing powers or gaps in the problem cause problems. So to go straight from squared to gone is skipping the first power. Rewrite it with an x to the first, but that would be changing the problem, wouldn't it? But not if you make it a 0 x to the first, because that's nothing. I've literally added nothing, right? It'd be like if I gave Maddie no dollars. Would somebody go around, she's the teacher's pet, I saw him giving her nothing. You know? No, okay, it's nothing. All right, but the same thing's going to be true here as well. I start with my x cubed, but class, I need to have a squared power, and I don't have one, so what do I write?
0.
X squared. All right, plus 0x squared. I do have a first power, I'm going to put that next, and then the gone moves to the back. So notice how I changed this to become this. Make sense? All right, now then, same steps. Work with me at your seats. We're going to divide the first by the first, and of course, x cubed divided by x squared, class, x. I'm going to multiply to get x cubed, to get 0x squared, and to get x. And then, of course, I need to add the inverse. So I'm going to change all the signs, and these cancel, and these cancel, and these cancel. I had nothing. And I just bring down a negative 3. Do I have enough to do any more division?
No.
I'm done dividing already. That's my remainder.
Fraction.
And we're going to make it a fraction. We're going to put the sign in front of the fraction bar. We're going to put the 3 on top. Now, when you copy this down, do you have to write the 0x?
No.
Can you?
Yes.
Sure, if you want to. I'm too lazy. I'm going to write x squared plus 1. And weird things like this can happen in Algebra 2. Stick with the process, follow the steps. Questions on this. Homework for this evening is to do, or for the weekend. Much shorter, by the way, than last night's assignment. That encourages your heart at all. Page 18, numbers 1 through 8 and 12. Page 18, numbers 1 through 8 and 12. We'll take a look at all of this on Monday in our next lesson. And I told you guys in Algebra 1 there are some shortcuts we can use sometimes in our next lesson. I'm going to teach you a shortcut that there are times you have to do this, but there are times you don't have to, and we can go a lot quicker. And shortcuts are coming in our next lesson. Have a wonderful weekend, and we'll see you next time.